Hello YouTube, this is Jesse for Statement PKs. Welcome to another tutorial. In this tutorial, we're going to continue where we left off in the last tutorial. And as you remember in the last tutorial, I showed you how to visualize the solution of the Laplace Poisson equation using GNU plot. And as I told you in that tutorial, in this tutorial, I'm going to show you how to do the same thing, visualize it using VisIt. And if you don't know what VisIt is, you need to go into my other tutorials that I show you in this tutorial here, visualization tutorial 1. I show you how to install it. I show you how to configure it and test it. So I use testing here, and I also here I show you how to run Python scripts. So if you don't know what I'm talking about, you need to watch those tutorials and come back, and then you are able to use the VisIt library that we're going to be using here. So the first thing you need to do is clear this, and we gotta make a change to our program, because in our program we were outputting into a GNU plot public license file. So we got to change it to an extension that we'll be using. We'll be using VTK. If you watch my tutorials, my VisIt tutorials, you will find out that VisIt can handle over 120 different extensions and more. 120, that was last time I checked. But I believe even more. It's incredible the amount of extensions and formats that it can handle. So VTK just happens to be just one of them. So let's go inside and change that. And let's go to the end here and make that change. Because if not, we cannot visualize it. And there it is right there. So now we go into gear and change it from GNU plot into VTK. And here from GPL extension to VTK. Close it. Yes. CMake to run it again. Make. And it's going to make the executable that we can run to create it. And if we check, there it is. So now we're going to get another file called solution VTK after I run it. When I run it, it's going to solve the equation just like it did last time. It's going to give me the number of active cells, number of degrees of freedom, the starting value, and convergence steps. But it also, most importantly, it gave me a solution. It's a VTK extension. So now this has been created. So now I'm going to go into my VisIt. If you watch my tutorials, you know what I'm doing here. I'm in my user local VisIt after I downloaded and installed it in my system. I'm going in the binary directory, and I'm going to be running this guy right here. So let's go run VisIt, and there it goes. So it opens graphical use. It opens two windows: the graphical user interface, which is this guy right here, and the viewer window, which is this. So if you want to learn more about it, watch my other tutorials. I go into detail of what all of these things do and how to do all kinds of cool stuff. So I'm assuming that you know how to use VisIt. So you're gonna go into open, up one directory, another directory until you find home. Just go, and then I'm going to find my Deal.II library. Find my examples, step 3, find the solution VTK, and then I open it. So now it's here. I open the database. which is right here, the source. And then now, in order for me to visualize it here in this big huge screen there, I need to add some plot attributes. So let's do pseudo color solution. And at the moment that I choose it, there you go. Now if I look at it, there it is. And I cannot do much with it yet, so I gotta do a couple things to visualize it. And as you remember, it's the top and going down. So it's the same thing. The elevation here is the top and then going down. So it just meets all the requirements that we saw with GNU plot. So now let's add a couple more attributes to it. Let's do a contour solution and then draw to make the contours, but that's too many. So let's reduce the size. I think it's what, 1, 2, 3, 4, 5. Let's go to 5. Change the opacity because it's too. I mean, you can play with these. And then 5, which is magenta. So let's do apply, and there you go. Close this one, and as you can see, it's a lot better. It's not perfect, but a lot better. Now let's add another attribute. Let us add now what, mesh? Let's do a mesh. Then draw, and now let's do an operator attribute, which is this guy. Let's do a transform, and let's elevate it so uh, so it didn't take the match. So let's do, and then draw. It doesn't like it. So let's close it here, draw. Let's close this guy. And then I just want to see it. This should be enough to show you. There you go, yeah. I just wanted to show you the profile. I mean, I was trying to show you the mesh also, but that's fine. And there it goes. You got your solution from 1 to -1, and you have your elevation, and you can see the contours, lines. And like I said, you can do all kinds of stuff with this library, with this visualization library. Watch my other tutorials and you'll learn how to use it, because we'll be using this a lot from now on to visualize other equations as we solve them using Deal.II. But this is the end of this tutorial. If you like this tutorial, please click the like box, subscribe to my channel, and I will see you next time with another tutorial. Have a great day. Take care.